Guten Morgen, bonjour.
Guten Morgen, Professor. Guten Morgen.
Okay, very fine. So, what are we going to do today? We are going on and talking about the Kotlin programming language, our first lecture, and afterwards we go on with Android, especially. So, where we are at the moment is, I think we are quite far. So we are doing object-oriented programming with Kotlin already, and have learned more about inheritance and constructors, class members, inner classes, abstract classes, as well as properties last week with the special getter and setter, and interfaces. So I think we came down to interfaces. Let's have a look. I show it in our last program. So we had a interface here and could have functions defined. This is a specialty here for interfaces, and if we derive from this interface, it's like derivation in for normal classes. It's in implements this interface here. We can redefine functions or use functions which are already defined and just call them.
Excuse me, Professor, would you please share your screen?
Oh yes, okay, yeah.
Okay.
Thanks for this hint. Now you see what I see. So we had a interface here, and this interface is having a real method. It's already defined here, and another one is abstract. And our derived class through inheritance here implements this interface. The compiler knows, okay, I want to inherit from this class, but it's not a class, it's an interface, so it's possible to do so because all methods are public and it's an open class. We have to override functions like this one here, which are abstract, and we can override them here. So we have to, because it's mentioned here, all classes which derive from my interface have to override this function. I can't leave it blank. And yeah, this is another case, a function which is calling this foo method. It gets a object of type of the interface type, and we can call this interface method on this type, and it is used here. Yeah, that's all. I think this was the last point we talked about last week, and today we go on and have a look at additional features. One additional feature is a new visibility keyword. We can have classes visible only in the module. So you know this maybe if you leave it blank in Java, we have already module visibility there. It's package scoped if we leave it blank, so it's a similar to this internal keyword, but we can have it especially here, give it or annotate it to the class and get this internal state. The default value here is public. You know, in Java the default value is internal, and here the default is public, like it should be. So I think it is more self-explained. If you define a class and you don't write anything, it is should be a public class. And if we want to have the if we want to shrink the visibility of this class, we should use one of the other keywords to say, okay, it is restricted for the use of this class is restricted to maybe the module, to inherited classes, to no one. So, but classes can only have public or internal, and the other things are possible for methods. So we can have those scope defined for everything, and we can show it directly with a keyword. And if we don't have a keyword, it is public. So it is maybe quite a good rethinking of the keywords, since we have public, private, and protected in all object-oriented languages available that care about the languages that care about visibility in classes and objects. We have that, but on a package scope in Java, we created maybe a new one, which is package scope, but did not define a keyword for that. Now we have one. It's called internal. Okay, that's one thing. I think we don't need a special example here. Internal means in the same modules or all files which were compiled together. Then it's visible to this. More interesting for us maybe is the next point. The next point is extension. So what we already know is we can extend classes through inheritance. If I have a class and I miss something in this class, maybe a method, or a method is not doing the right thing, I need another newer version of this method or of a attribute as well, I can derive from this class and extend it, put some more methods into this class, put some more attributes in there, and the polymorphism is using those automatically. So if I have a derived object, I can use it everywhere where the base class object is used, and my special redefined methods will be called on this special object later. This is done automatically, and we secure that the polymorphism works, and it is the main or a core feature of object-oriented programming, this polymorphism. And normally we want to have it, but in some languages, if you maybe think about C++, you can choose if you want to have polymorphism activated or deactivated. So in C++, if you want to have polymorphism, you have to write the keyword virtual in front of your function definition. Then you get a pure virtual or a virtual function. And if you set the value of this function, if you define it as null, then it is a pure virtual function. So it only works with polymorphism, and we have to rewrite it in a inherited class. If we leave this keyword virtual, so if we don't write that's a virtual function, then we do not get any polymorphism on that. We can redefine it in a inherited class, but the methods are not automatically chosen by the runtime system or during runtime. And this is a similar approach like here with these extensions. We can extend classes without inheritance. We can extend them from outside. So later on we make examples with the extension functions, but let's try to extend something here without inheritance. We do some stuff into a class without inheritance, so let's write a simple class. This is my base class for today. This base class does not define a method, but we could say we extend this class. We want to have a method, maybe this method called base is the class name, and the method could be base method. This method is printing something out. This is a extended method, extends class base. I have to create a object of this class, and on all the objects of this class base I can call the method. So this is a base object, and base method can be called now. So I just put this method into this class. You see this class is empty, and now I put this method into the class, and it's a method of this class. If I inherit from this class, you see this method extends class base. It belongs to class base now. Is a member of class base. Better to call is now a member of class base. So we just put a member into the class from outside. If we inherit from the class base, maybe we have to open it up, make it open. We can have a derived class. Maybe it's class another class derived by base. And if we have another object, we can call it. We could call this method too. So since this another object is of the same type, is of type base, we can call the method on base. So we get this method called on another object too. This is extension without inheritance. So this method is put into the class base without inheriting. If I want to do it with inheritance, I should have a fun method here and say, okay, I want to put this method into class base. Another method extending base. If we now call this method, we will get this version of the method, because here of polymorphism we have another object, and the methods from the class, which are defined inside the class, have precedence over extension functions. So we should print something. But you have already seen the text is away, has gone, and it is because this method is called now. So this method is called here now, and this one not. If I want to have the base method called, I can do it inside here, like super method, and it is super is not an expression. You can't use it like super at base, or simply base. No, why not? Hey. So we still have this. We don't have it because this method here has precedence over that, I think. If we want to do this here, and if we want to use this super method, we should define it inside this class. So we use polymorphism. This is without polymorphism here. Okay? But actually we do not need this inheritance to get this method called, which extends this class base. So this was a example for those extensions without inheritance. We can extend attributes too. So if we want to define a attribute, we could have this in the class base as well. And this is not a function, it's a value. It's called base number, maybe should be an integer, and we should have a getter function for this, returning maybe 1. This is a special solution in Kotlin. We have a value. It's not a member. This will be a extension value. It's not a attribute. It will not be a attribute of base, but a member. And since it is not a attribute of base, it will not have a backing field, so we can't initialize okay, I am not available at the present. But it's Hof University. I go on the phone. Please, excuse. Entschuldigung. Ich bin gerade in der Vorlesung. Ja, ich rufe dich nachher nochmal an. Einfach nur zum Quatschen ein bisschen. Okay, ich kann dich in der Mittagspause nochmal anrufen. Ich mach's, ja, mach ich. Okay. Okay, thanks. See you, bye, see you later. So, well, please excuse a colleague of mine from Hof University, and but it's nothing. I called him earlier today, but he wasn't available, so it was a returning call.
Kein Problem.
Thank you. So we can't initialize it directly, but with the help of a get method, it is usable. It will be usable. And we can call it now. We have this another class, and we can use the number on our another object too as attribute. Just as would it be a attribute from this object. You see, I access this as a attribute, get the get method called, and get returned this number. So I can return things from somewhere, from anywhere. Yeah. So this could be a return a object method, return something else. Can be everything I return here. But it's very interesting. I call it like a attribute. This is a nice thing what Kotlin brings here into the object-oriented programming. We just extend classes, and through inheritance this extension stays available for derived classes, and then we can just take maybe standard Java objects or Java classes and say, okay, now I bring some new stuff into this Java class through extension. I don't have to break the object-oriented principles that are available or that are defined and that are used in the Java language and in the Java objects and in their object tree. I just take these standard objects and bring extended functionality, some value-added methods and attributes into the normal programming, and then we have this is the Kotlin point of view. I just take standard stuff from maybe another standard library from C or from C++ or Java, and bring extended functionality to the already defined classes, so make some new methods that accept maybe lambda expressions, and there are lots of such extension functions in the standard library of Kotlin, which just extend the standard objects from the other programming languages that are usable in Kotlin here, and we can use nice Kotlin extension functionality with all the Java classes too. And this is very, very interesting, what Kotlin has found to do here. It is the Kotlin compiler has to compile this method into this class, has extend this class, make this method available, but it does not work with polymorphism here. Actually, it is derived, but if we redefine this method by ourselves, the extension method is lost somehow. Okay, next slide. We still talk about, that's what we had already. We still talk about data classes and objects. Now we come to a special flavor of classes, the so-called data classes. They are special here because we get some more value-added things created automatically. We don't have to write maybe a equals or hashcode function pair. It is already generated for this class. We have a special toString version which creates this output. So we have the class name and a list of attributes. Those are named and they are presented with their values. We have special component numbered functions, each component of a data class. So a data class is similar to a field or a set of a table in a database. So the fields are numbered and we can access the every field through a positional number here, and this is used for decomposition. We have a generated copy function, so there will be maybe some copy constructor. A copy function is generated. We see it on the next slide, and yeah, let's have a look at this. Let's make an example to this one first. I throw this away once and we try to write a own data class. So data classes start with the keyword data and just give it a name. I didn't have a look into the chat today, so I should say good morning to the chat users too. So data classes, just give it a name. We have seen this example with the user. The user had a name, and this can be default John, and it can have a surname. This could be Doe, and it could have should be from a distinct type. Could have a age, maybe integer, and the value could be maybe 25. So to see it a little more clean, I make it under another. What we get is normally a class with those three attributes. They are accessible. We can only read them, so we have only a getter method for those available. They have standard arguments. I can create users with those parameters here, and I can leave them blank if I want, or give them a value. This is the same thing if I leave this data out, so it is a real class. I can create users. So this is our user John. But if I want to print John, I get, and you know this, I get only the class name and the inheritance, so I get a toString version from the class object. If I try this out, you will see it's this typical toString realization from the class object. We get the class name and we get the hash code printed in a hexadecimal form. If I change this now to data class, because I say, okay, this is a class just having some data fields and making a class out of this, then we get this beautiful version of a toString method. This is 1 point. So this gives us just some additional stuff for this normal class. The attributes, everything's the same, but we get some more methods generated here, and we have some additional features. We can destructure these classes. We can destructure them and we can copy them. So destructuring and copying is maybe on the next slide too. Destructuring could be, I want to have the name and the surname from John, like this, as values, and then I can print maybe it like this. So since he has 3 attributes, I will only see the first 2. So it's Doe John. If I want to have the age as well, I can write age here. This object now is destructured into its components, and therefore are these component functions. So the first component is set here. So this is the same like I define val name is John component 1. This is this name field. And it still works. So this is what you get if you write this expression and the values which are named and not left blank. So here is a placeholder. This is a left blank, is a underscore. If I write an underscore where you can write a variable name or where a variable should be declared, underscore local variable is it called, and this underscore could be used here too, I think. Let's try. Is a local variable underscore. No, it's not working here. You see, won't work here. It's an error there. But we can leave it blank. This underscore is for leaving things blank. If I just want to have the age of this person and I'm not interested in the name, I leave those things blank, and then I get the only the last field like this. I could do it as well like call component number 3, but I have to know about the position. It's the third argument, and the position is given here. So this is the order for the attributes, and it gives us the position of the third or first, second, and third component, and we have this numbered component access functions here, accessible to. They are automatically used when destructuring a object into its components, and I can access the components named like this: age or John's age should be the same. So it's we get 25 actually here. If we change the order, we have then the name instead of the age. So the age would be doe, but it's actually 25 because the order has changed here. So let's reorder it back to the original version, and then you see third parameter is age, and then it will work. But we don't have to care about this number because it's more easy to see. Let's try it like this. Gives us the same, and the numbers are made available automatically. Yeah, this is the Kotlin language. Was a question from in the chat. Good. So far destructuring and now copying. We can have a copy of John. There is a copy method available. Maybe George is a copy of John, and this copy method has all parameters named available and has a standard version for those. It gives, we can copy it and then he is the same object again, but we can change the name if we want to say, okay, he gets another name. This is now George. Then we get George. So this is a method created here. If we leave this data out, we can't destructure, and we don't get the copy method. So I just want to show you how this copy method looks like. There would be a function copy in there, and we have named parameters, so we get name is a string and has this name as default value, and then we have our name as default value. Let's say normally we should have this name as default value, that's right, and surname is this surname, type is string, so we get the same types, and we get named parameters which just make a copy of this object, and then we have age, it's this age. Now we just say name or return a user, so we return this user here, gives us a user, and we return user name, surname, age. This is this copy function which will be generated automatically, and you see this is here the function body, this is the function declaration. We get a copy of we get a new object with the copied values in this case, and if we change one or more values, we are free to do so. Since we have named parameters, we can bring the names in the order we want by ourselves. So we could copy name George, and then we only get a changed name here, and if we want to have the age changed as well, age should be 27, and then we get a copy and those parameters are changed. So it's really nice to use it, and this method is already there. We don't have to write it because it's already there. We can leave this body blank and say it's a data class. The method the copy method is already available, and we can use it as well as the destructuring. And if we want to make a list out of the two persons, first we print George out so that we see George has a other name. It is the object with a George 27. Give the capital letter in front, so names are written with capital letters. Let's make a list out of this. We put both into a list. We do it with list of, and just put in John and George. Now we get a list. We could say it's a list of users, so it's a user list, and for every value in this user list we could do this like here. We want to have name, surname, or age from the list, and print all those data fields. Maybe then we can do it like this. Just create a list and go through the entries and destructure your data fields. And if you don't want to, if you want to skip something, you can leave it away. If it is in the last position, we can skip it. So we just get names, and if we just want to have surname field, which is in position 1, we have to leave the, or we could leave the other fields blank. We could use it with a name. We could say, okay, don't use it. We give it a name, some name, and we don't want to use it, so we can leave it out. But if we don't want to think about names, we can leave it with the underscore. We can leave it blank. Don't use this field. Don't use this parameter. We get the same again. So it's quite a nice thing what you earn if you write this keyword data in front of your class. Then you get some additional methods created if you want, as well as this copy method. So it's a copy constructor. The data class has some restrictions, so we can't leave this blank. So there must be at least one attribute defined inside the primary constructor. At least one. Have you any questions?
Yeah, I have a question. With regards to the structuring. So, like, you said we have to follow like the based on the constructor, the member variables that we are passing into the constructor. So, like for instance, if we don't put like the underscore, like let's say we only want to get the age, and we just put only age there, would Kotlin be able to still recognize it, or we still have to like put the name as underscore, then the age based on how it's arranged?
When constructing this, so we could just have the age here, age 30. Now John is 30 years old. You mean this? Like that? If we say this
So
is
yes, so
yeah.
yeah, so if we remove the for like for instance, if we remove the son name and the underscore from the for loop, and
Here?
we leave only age,
Oh, this will not work.
would it work? Okay, okay,
This will
okay.
give us the name, not the age.
Oh,
So
okay.
it is
It's based
component
on
number 1, and it gives us the normal name. So
normal
it's
names.
this is component number 1 now, and
Okay.
this is just a name of a variable. It will not be
Variable.
recognized like here. This here
Okay,
positional
okay.
parameters. You are right. This question was
Mm-hmm.
this question as well. This is a positional, a named parameter. It can be used in this parameter list, but this is not a
but not.
parameter list in this ways. It's like a how you would define a vector in mathematics. You have those braces around, and then you just write the dimensions, and this is the first, second, third dimension, and maybe this is a three-dimensional object here, and we have this always the first component.
First.
Yeah.
Okay. Okay. I
So,
understand.
okay, thank you. Another question in the chat here: can I inherit every class like the data class, or is it specific?
I was the one who sent the message. It's the same question I wanted to ask. I posted on the chat.
Ah, okay. You put it
Yeah.
there. You put it there. Can you? We
Yeah,
can
yeah.
inherit from data classes. We can
Okay.
actually we can have special user classes. Maybe the class admin user, which has a password, special password, and then we could say we have value password string, and it's called secret. This administrator is derived by a user, and therefore we have to open this class, then we can derive from it, and maybe we have to, so no, we have to remove the data. Okay, I thought we could use it in inheritance too. Okay, we have problems with the component functions. We have problems with the components. You've seen that. We have problems with the component functions. Now we have the admin user is a data class. It is derived from user. We get some component functions, but we cannot use the simple user. So now we get real problems. Do I have structuring? You can. Okay, you can't inherit from those data classes. If we open it up, you see, we get problems with extending those because of the component functions. The component number one function is this component here, and if I derive from that, this is not component number one. This should be component number 4 then. And this is something the compiler is not doing. So data is incompatible with open. We can't open it up, and that's why we cannot inherit. It's a final type. Yeah. Oh, so you have written in the chat. Okay. Good. The next thing is, that's what we had, data classes. We have talked about this. Now we have some boundary construction conditions. We have to follow the primary constructor needs to have at least one parameter. We have shown all primary constructor parameters must have the value or the variable annotation, so it must be attributes in the primary constructor. They can't be abstract, open, sealed, or inner, so we cannot inherit from the data classes. And but the data classes are able to implement interfaces, so we can have additional methods in those classes. Those are real classes, and we can make them compatible with interfaces and interface methods. They are able to inherit, but they can't be inherited so far. Okay, this is what's additionally we have to think about if we use them. So this is a thing we already have seen here. Destructuring. The copy constructor was also presented. and it's much more like this. We can reset the body of this special copy function I have presented to you with the with this code here. Just say, okay, this is the return value of this copy function, and the name and the age is put in here. And if we don't redefine it as a parameter for the copy function, we get an exact copy, or we can change some attributes and get another user. But we need one. The copy function isn't a static version to create objects. It is just a function which copies something, so we need a object before we can use the copy function. In the standard library we have two typical standard classes which are actually data classes, and these are the classes pair and triple. You know them maybe from C++, they are there too. We have their pair and triple as well, and they work similar to this data classes here. So we can simply create lots of pairs, especially in maps. So if we think about maps or coordinate systems, something like this is a map 2, we could use pairs or triples. We could use a pair and say it's a pair of two strings, and then we give in two strings into this pair, and maybe it's John and Doe. And we can destructure this value like we want to have a name and a surname, and print it too. Since we know pair is a data class, we can use it in the same way, and we can copy it as well. But here we have to use the attribute names, which is called first and second. And maybe again in creating a list of both, we just want to have name and surname from a list of, excuse me, a list of pardon, a list of pairs of maybe strings and inside there is John and George. Thank you. Okay, and yeah, if we want to have the age, we could use triple integer and put into third parameter the age. One is 25. If we want to have the third argument changed into 30, we can do so. And now we have a pair, not a pair, but we have triples. get the age now as well. So this is fine. We don't need to have this. You see it is gray. You can create it. Because those objects are all of the same type, it is possible to create a list, and yeah, the compiler can check if if they are all conformant to those data classes. So if they are destructurable, it's what the compiler actually checks, and then it will work, because he can derive, or he can how to say, he finds out the data type of those elements here, the most common one. So if I give in something else which is not the right type, then it will be an error, because they are not of the same type. So now it would be any, and any isn't a data class. So this is wrong. It can't be destructured. But this can be destructured. Good. Let's see. Let's look forward. If you have questions, you can ask, and I will move forward. The next thing we will have have a look at or think about are sealed classes. What are sealed classes? If you think about classes and inheritance, it is always possible to inherit from a class. In Kotlin we have to annotate this class with the keyword open, or we have to make it abstract. So we have to explicitly allow inheritance. Interfaces are abstract by default, so it is allowed to inherit from interfaces. But since we allow inheritance, every class in every module is able to extend my class's objects or my classes, and therefore the extended versions of the objects can be used where my own defined classes are used in functions, methods, and in other classes. And the polymorphism will assure that other method versions, extension methods from maybe a other programmer, are then used. So a programmer could hack into my code if he extends my classes and uses his own versions of his method, which are then called if he puts his objects into my code, into my system, and then his method will be called, and he could grab information and write it into a log file or something. So if it is possible that this programmer, or if this programmer is able to bring his own version of my classes and his objects of those classes in my software system and runs it, and in our modern time, if you think of application servers where objects come from another host computer and are copied over network and then will be run on another machine, then we have problems with inheritance as well, because you could inject foreign code and run it on another host where you don't want to run that code, because it could be insecure, it could steal data, or it could crash your software. And we can seal our classes in this way. We can say, okay, I want to allow inheritance, but I want to control who is inheriting from my classes. How can we do it in Java maybe? In Java we could scope this class to the package level. That's then the inheritance is limited to the visibility of this class. If this class is only visible to his package, only other classes inside the package can inherit from the base class. But if I want to give this class into another package, which I have written by myself as well, I have to open it up for other packages the visibility, and then I have to open the inheritance. Therefore, how is it here in Kotlin? It's similar here in Kotlin. We just write the keyword sealed, and all classes which inherit from this base class have to be defined in the same file. So it is on a file level. We have to define it in the same file. In this way, it's quite a little bit harder than you could do it in Java already. So we talked about you just control the visibility of your class, and if the class isn't visible, you can't inherit. But we can make it harder. We can say, okay, we define a abstract class. This class is visible to everybody, but it's sealed actually. And since it is sealed, we can only derive from this class if this derived class is written down in the same file as the abstract class. Yeah. So if you remember, if I make the abstract class not visible to others who could inherit from this class, then the other guys cannot use this class. Yeah. If I inherit from this class, I must see it, and if somebody isn't able to see this class, he can't access methods from this class. And if I have a inherited class, this inherited class would have to redefine everything which is in the abstract class and make it somehow accessible from outside to use it. Yeah. You remember, abstract classes are able to have defined methods and pure virtual methods which are abstract. The abstract methods aren't a problem because during inheritance I have to rewrite them, and then I can decide to make them public, private, or protected. The non-abstract methods in a abstract base class, they aren't able to use for somebody from outside who isn't visible, who can't see the base class, who hasn't access to this abstract base class, and this is a problem. But we solve this problem here we can say, okay, we have a abstract class which is visible to everybody, but we seal this class. Only the programmer who founded this class is able to inherit from that. So this closes a small gap which was open. On the one hand, you want to use methods, so just let's make a example, then we see it. Let's define a abstract class. It's no problem. We define a abstract class. Abstract class my base. Now a abstract class. Now the class which inherits from the base class is a subclass, my subclass. Derives from my base. This is the normal approach. So this abstract class is visible to everybody. Everybody can inherit from this class, and we write some stuff, access this stuff, and rewrites this stuff, and can be used since polymorphism is working, can be used everywhere where my base is accepted. Let's write a function which could accept my base objects, do something with my base, accepts a object of type my base. Just print it out or do something nasty. We want to print it simply. But you can imagine we could do what we want. We can actually call methods on this object, and we will further do this as well in our example, but step by step. Let's go. We create a object of my subclass, since it isn't possible to create a object of the base class. Yeah, I can create my subclass objects, but the base class is abstract. I can't create, but my subclass objects I can create. Now I can do something with my subclass object. Oh, yeah, it's like this and like that. Okay, now it's okay. We know we get my subclass. Now it is possible to have methods here which are abstract and non-abstract. Maybe there's a non-abstract methods which returns always 1. Could be the function good, and this gives only 1, and could be the function critical, which is abstract. And gives a integer number as well. Now, since it is abstract, all classes have to rewrite the critical function, returning maybe some other value, like this. And we could use the value good too. So we can access this method because we can see the base class, we have access to the base class. Since we have access to the base class, we can derive from the base class, and we can use the methods from the base class. Okay, now I can use the critical method here in my do something critical with my base. We get at this moment we get 0 because 1 minus 1 is 0. An attacker could rewrite these good function 2. I rewrite fun good and say good is now 2. But I have to override it, and we see it is really safe. The design of Kotlin is really good, safe. We have to open it. This is the first thing. We have to make it open. Now the good function is open, and we can do critical stuff with the good function too. It is open. We want to open it, so now it is open, and someone could change things. So the critical things have changed because the good things were attacked in this moment. If we want to have this open and say, okay, a good programmer is able to do good things, and he just wants to, or he just has to rewrite this good version so that the critical version gets 1 and not do this way, rewrite good with -1, or rewrite good with 0 to get a negative value. So he could do bad things with the method good. Maybe this is what an attacker wants to do, and we want to do maybe this one. So it is only good to have good the value 0, to have a bigger value 1 or 2. So the values 1 or 2 are maybe good because we get in our critical section we get 0 or 1. So true or false maybe as output, but since we make smaller numbers for good, smaller than 1, so maybe 0 or -1, we get negative values here in our critical section. Okay, we want to open it up, but we just don't want that anybody, we just want to control who overrides this function good, or who accesses this function good. The function good can be accessed from everybody who is accessing the subclass, but we don't want that everybody is able to rewrite this good function. And therefore we just say it's a sealed class. If it is a sealed class, I have only the chance to rewrite the good function inside this file. Outside this file there can't be everybody can see this class. Everybody can use the methods of this class. So everybody can do something with my base, and he can use it in a critical section, but I am the only one that defined this class base, and I am the only one who defines the subclasses of this type. So I'm the only one who is able to do good or bad things with this class. And if and let's say I don't want to do bad things with my own code, then I can assure that there can't be somebody who inherits from my base class and rewrites the good function with a bad version, which brings my critical section to a crash or to do something nasty. This is the idea behind. Yeah. So we seal it. We can control the number of derived classes, because the number of derived classes has to be the number of classes defined here and derived by base class. Another thing in this with the sealed classes is we can use the when expression for type checks. We can use it in Kotlin everywhere where we have types. We can use the when expressions for type checks, but we have to use the else path. And this is here, the compiler here is able to count all classes which derive from our abstract class. And if we do when checks on the abstract class, which is sealed actually, so it's a sealed class, when we do the when checks with this class, we don't have the need of the else path, because we control the number of derived classes. So let's try to check. Make a small check function. Check a MyBase object and do it with a when expression. So when B is my subclass, then return 100 points, and we don't have the need of this else path. If I take any other class which is not a sealed class, maybe I take class my subclass here, then we have to use a else path. Now we have to have a else, which gives us maybe nothing or 0. We don't have the control is how many classes are compatible with this class. So how many classes are inherited from this class. We can't control it. But we can use a sealed class, which is my base, and in my base this else path, you see it's gray, it's obsolete because we check all subclasses of my base. If I have another subclass of my base, then we can have the else path available, or we say it's another subclass, then we give 20. Now you see it's similar to the switch case in Java when we know the number of objects possible, and here we have the number of types possible available. Then we can do the type checks here with the is command. These are type checks, and the number of types possible can be count. The compiler is able to count the number of types which derive from my base directly. If I derive from my subclass, I indirectly derive from my base class too, but the indirect members aren't recognized for this approach in this when case. So only the direct subclasses are count. Have you any questions? I hope my English is good enough that you understand what I want to explain. So we get this 100, or we get 20 if we put in another subclass object. Okay, this is how Kotlin is doing this with a sealed class. Here are questions in the chat. Okay, we already talked about this one. That's right. And next, sealed classes. Okay, now we advance to generics or templates. Template classes, also called generics, are in a modern language. We can't miss it in a modern programming language. That's why we have to use it, or we can use it here. It is similar to Java. But we can emerge or interfere type parameters from the context, and don't have to write them everywhere when it is clear. So let's make a example to this. Let's write a template class and make it inferred from the context. So our class could be a template. So class base now accepts a data type, and inside we have some value which is called maybe name, and it's of type T. Could be a data class as well. If I want to create now my base objects, I just write value John again and say, okay, John is normally a base with a string and his name is John. I can write it like this, and you see what I can leave out is I can leave this out. That's why this string can be inferred from the context, because the parameter I use here, this is the T parameter, I use this T parameter here, so this is a string and T will be a string, and then the only correct way to construct a base object is if there would stand string. There would be we would have to write string in here to make it correct, and the compiler is able to infer this from the context and presents us a base string object. So actually we get base string. Yeah, and we can destructure it to a value. We could write it like this: 2. This is John's name. And print it out. It's really cool because this is destructuring is possible, and we have here a template. We can put numbers inside. So if I want to have not John's name, if I just want to have some value here, anything, just print anything. And we have this anything in the data class. I give here anything, so 100. And then anything is 100. So templates is a very nice thing in modern languages. We just substitute the class types, and everywhere we have this. Inside this class we just define it with a T. What are you building? I'm building examples with Kotlin with the help of IntelliJ and my script. Okay, type parameters can be constructed from the context. We can omit them. We have type variants possible here. So type variants is something where this is not a variant type, because I just create base objects with a special type here, and variant types are the Java thing. When I write in Java, I would write t extends maybe object. This is not in Kotlin, it's wrong, but in Java you could write t extends object or t super object or star super. That's right, star super t. You can write something like that, or star extends t. And then we can use this class with a it is open to lots of classes which inherit from this type. If we create it then with a string, all classes inherited from string can be used with this template too. And if we write super, all classes which are base classes somehow of this type can be used with this too. And this is what we call type variants. In case of type variants, we have some problems in Java 2, because we aren't able to give the right data type back sometimes. And here in Kotlin you can say which parameter you can say, okay, we have a parameter which only comes out, is a return type of methods, or we have a parameter which only goes in, which is in parameter lists of methods. So this can be written and this can be read. Just read out, give out, read out those types and write into those types. And here we have producer extends and consumer super. So here we can have all the super types, and here we can have all the extended types. If we write into maybe a container, and this container allows all base types and says they go in, then we can write into this container every type which is subclass of base 2. And if we say a type comes out of this container, this is the thing we read from this container. If we only read subclasses from this container, we can read from this container all base classes too, because they are compatible with a subclass. So in reading form, we can say all superclasses are allowed. This is the star extend a star super projection here, and this is the star extends projection here. Oh no, this is the star extends projection here, and this is the star super projection here. That's right. So producer extends and consumer is super. And yeah, and star projection as well is able to do here. We can have star allows read access to base type and prevents write access. If we use the star projection as we use it in Java, we have only read access to the base type and prevent write access. But if we want to have read or write access, we should annotate in and out, and then we can put in derived classes too, or we can read out superclasses too. We can read out extended classes. So out is producer out. Producer extends. This is the extends, and this is the super. Consumer super. You can put in base classes and read out extended versions. Okay, I have a example here. Let's try it out. What this means. So it simplifies the Java approach a little bit. For my example, I use a interface which just produces, which has simple method. It gives a type out of this interface, and it's a out type. So it just has a method with which gives a object out, maybe next gives us a t. So we have a simple interface, and it has only one interface method, and this method returns our template type, and this can be marked as out, and all types which extend t can be given out too. If I leave this out, I can only give t back. So source t, if I have a source t, it only returns t. If I have out t, it is able to return subtypes of t too, and not only t's. Now we make a demonstration function. We give in some strings, is source with the string type, and here we can have maybe objects of type source any. They are compatible with our strings. Not objects, because object is a keyword. We have seen that. This is okay, because we only get t as out parameter. T is an out parameter. So we get strings out and can cast it to any base class. If we use a interface in the other direction, maybe the comparable interface, comparable, we give a type into the function, could be the compare to operator. We will talk about operators later, maybe not today, maybe next week. Oh, next week, yes, next week we have next week we have lessons. Operator compare to. Another T gives us operator fun, should be a function, and gives us a integer value. If we now demonstrate this comparable with a number, maybe we can compare to a double. The double type is a subtype of number. This is okay, since the double type is a subtype of number, and number is going in. The stream is away, okay. No, it's there. Stream is there. So this is okay because double is a subtype of number, and we can compare it with the others. So this type goes in, and all subtypes of number are now comparable to this. Not only number, all subtypes too can be compared here. And as well, we could have another value which is a comparable double, and this comparable double is maybe x, and this is okay too, like double is a subtype of number, so it is compatible. If I take this away, we get the error here, because this would be okay because it could be a number, it can be cast to the number, but this won't be okay because it is a comparable number and not a comparable double. So this is strong, it must be identical, and this is less strong. Subtypes are allowed here, and the same thing here. If I leave this out, it is not able to cast to any other class here. So if I say this comes out, then all superclasses are compatible. Okay? So open it up for inheritance, and compatible classes are superclasses, and here compatible classes are subclasses. Or better to read, this comes only out as return type of methods, and this goes only in as a parameter. Good so far. Have you questions to that?
Yeah. So for instance, if we're using the one with the in, so you said we can make use of like comparable types. So if we can use numbers and doubles, so it's possible we can use like big or floats in this situation also.
Yeah, that's
Right?
right. Yeah, that's
Okay.
right. This is right.
Okay. Okay. Thank you.
Yeah, you're welcome. Okay, allows then read access to base type only and prevents write access. So if we use store somewhere. More interesting to us maybe aren't those template and generics are interesting. So we have heard about out and in, and it's quite simple to use because out comes out of some methods and in goes into, and then we are able to use this super and subtypes. So it's more easy for us to handle than in Java, because in Java you have always to remember, okay, is it star extend, or is it t extends some anything, or is it something extends t, and how to write this. It's a little bit more, you have to think about a little bit more. You can make more errors when doing it in Java, and here you do, it's more easy for us to handle it. So something simplified and made more secure. Now, much more interesting for us are template functions, which are extension functions, which actually are generics. So they accept a generic type. We can extend classes and bring functions into those classes and make it, or write extension functions which work for all classes. We just write, so we have learned about or have seen today, extension functions. I can take a class, any class I want, and I extend this class with a extension functions. Just say class name, point, method name, and define a method. And this method is usable for all those objects of this class. Quite interesting approach. And now, much more interesting is a generic version of a extension function. I can write a extension function which is not only matching a distinct class, I can write an extension function which is compatible with every class visible, and therefore you can call this method on every object you can access. And this is nice. This is real nice. And that's what Kotlin is the Kotlin way here. So this is a really, really impressive thing. Extension functions which are generic. You could have so we make examples. Better to make examples for that, because we have lots of functions like that. We have this for loop, the for each version. We have the run and the let extension function, which is a generic, and we have a lot more things in Kotlin standards which is just made available through a generic version of a extension function, and it can handle everything. It's really nice. And the type, we don't have to write the type, because the type we use it can be left out, it can be inferred, and we don't see that it's actually a extension function if we call it. So it is transparent for us. We define it as a extension function for every class type you can imagine, because every type in Kotlin is a class type, and then we can call it on every object you can imagine ever, and you never have to write this to make it visible, because it's transparent. It can be inferred from the context, and then we can leave it out when calling this function, so you don't see that you actually use a extension function. And this is really nice. Yeah. So let's make an example how to do that. I throw this away. We start anew with the next example. Okay, we do this last example, and then we make our break. Okay, I'm sorry, but we have been running out of time today. We make this example as last part because I think it is so interesting. We can't. We have to do it. We write a extension function. It is actually a template function. We can put in every type we want, and we say we extend this type and put maybe a basic toString version into this type, returning a string, and the string returned is the string version of this pointer. So it is just the same thing like the toString version, the original one. But I just want to show how a toString version could be presented to every class and can be used to every object without derivation and rewriting it. Just make it as a extension function. Every class you can imagine now has this function available, and we can call it on every of those objects, and the type is inferred from the outside. So class a special class can now be printed out with a special basic to string version. You see, this is Kotlin Live, and it is one of the greatest advantage of this Kotlin programming language here. In this case, we have those generic types. We can have out type or in type, so this is we don't need here because it is the type name and it is free. We don't use, you see, we don't write something like we have to call a special type. So it's just like it's a member function of a object, and it's not only the special class. We just found this special class, it's empty, there's nothing in, but we defined this method, and lots of methods in Kotlin are defined in the same manner. We can implement repository and unit of work pattern with combination of generics and extension methods. That's right. Correct. Yeah, there's so much possible. It's really amazing. Okay. Now we make the break. So you get 15 minutes. Let's say it's almost 25. 15 minutes, 11 and 40. We go on. So in 11:40, it's some more than 15 minutes, but it's okay. Then we go on and come over to Android. Thanks a lot, and see you in 15 minutes. So I'm back, and we can go on now with our second lecture, talking about the Android. Therefore, we start to have a look what we have done last week, and yeah, let's go into the details. Last week we started to work out with the activity class and the activity life cycle. We have created a small activity, a small program, which checks the hooks we have into the life cycle. We see those stages, and we can rewrite and overwrite the methods here in in Kotlin or Java. We have done it in Kotlin, and printed out some text when this method is being called, and we tried to go through the ways here, through those paths, and try to see how can the user influence this the call of those methods when he uses his smartphone, or we are using the emulator. So how can I come around with those paths with the different stages in this life cycle, from creation of a application or activity until the activity will be destroyed? When are we going over stop and come back to on create, and when are we going over stop and come back over on restart and the start? So we found out that the most important thing is this on resume and on pause, because those players are always around the inner circle, the running activity. So it is visible to the user, and in this case, but it is maybe not more in the foreground, it's not more active, and when it comes back into the foreground, it is able to work with events. So the event handling is only done when the activity is in foreground. Then we can handle events. We have event handling if we pass this on resume method, and we don't have event handling if we pass the on pause method. We are still on the screen. Maybe there's some pop-up in front of our activity, so you know the Android system on tablet computers, which have a much bigger display than the smartphones, they maybe allow multiple windows, and in every window you have a activity, and if you have multiple windows, you can have several activities on screen in a running state. And here on this smartphone, we have only one activity in foreground running state, which is actually accepting events from the user. So touching the screen would cause an event which could be delivered to the foreground activity. That's what we have to a little bit keep in mind. We are active means we are able to handle events. Every event touching on the display will be delivered to our activity, and we can catch it and work on it. Otherwise, if something is in front of us, or if we switch from one window to another, if we have a tablet with multi-window Android system, then there could be several activities running at the same time, but only one window is active. There could be several activities visible, but only one is active, and the others are then stopped or maybe restarted. And if we don't see the activity, it is not longer visible, it is stopped, and but it can be started again when the user comes back and navigates back to this activity, if the if there is not enough memory, a stopped activity can be put out of the memory, the process will be killed, and if we navigate back to this activity, it has to be recreated in memory. So this is mainly a resource and memory allocation step, which is done in onCreate, and then we have this start and stop part where we can say, okay, now we are visible, now we are invisible, so we don't have the need to do things, or we could persist some things. If we are not longer visible, we could check is the user input the user has done already, do we have to persist it or don't we want to persist something, then we can choose here our decision to do something to persist and to present it back, because if we are in the stop situation, it could go this way or this way. So we are here is a crossing point in this case. It could be that we just will be restarted and we don't have to persist things in maybe a database because we will be restarted. It could be our memory will be destroyed and we have to persist things because they are lost on this road. If we go this way, things will be lost, and if we go this way, things in memory could be still there and we just have to represent it. So if we have maybe some text input fields and the user puts stuff into those input fields, when are they made empty? He does not persist something while he doesn't push save to disk or save to database, just writes something into the fields and switches. Because a phone ring comes, another activity comes up, he just wants to phone, and if this phone call is over, he automatically comes back to your activity. And what does he see? Does he see this? He should see the same things he has seen at the moment he left this activity. But you don't know if you go this way to come back or if you go this way to come back. As we know that, no, we don't know that because it could go this way or that way. So we should always persist data if we run into onStop. We don't have the need to persist data if we are in pause, because the stop point, crossing point, will come after pause if it is needed to stop the activity. But if we are only passing the onPause method, we don't have the need to persist things. We maybe have just the need to deactivate some stuff which we want to activate again here. So those parts belong together around the activity running state. And if we want to persist things, we should decide to do this here, because the resources in this way remain in this round, in this inner circle, remain active, remain available, and we just can represent them. But if we pass on stop, we don't know if we restart or if we get deleted. So better to persist things here, and the last chance to persist things is here. Okay, we found out in our emulator, the emulator goes mainly this way because he has enough memory. And if you have a smaller phone, I talked to you or I told you that my older phone is very limited in main memory. So if I start more than one activity in the foreground, the older activity will be killed and has to be recreated. So it is not destroyed, actually. It stays if I push this, and I wanted to show but it doesn't work so far. I come to the home screen, but somewhere must be this is only the home screen running, or what? Home settings, no. Somewhere must be a button where you can see there are several programs running. I don't know. It's this square button. Yeah. Now you see several programs running, so they are not destroyed. They are running, but they could be stopped. You don't know if they are stopped. So this is a other activity. You always get a activity presented. This is a activity. The user can see the running programs or the running activities, and he can switch between those activities, which are still a running process but not visible to the user. None of those activities here is actually visible to the user, because the actual visible activity is the activity which presents us this view. But we can switch, and if we switch back to our activity, and that's what we did in our last program, is that we print out the method hooks here down here, and we see we came over on start. We were stopped, restarted, started, and resumed. We went the right way to come back to our program. But we still could go the other way. We are in this list, but it could be that the memory is freed for other activities, since this is limited. You know, maybe if you watch your phone and you have 50, 60, you never close activities. Maybe some users never close activities. So they have every activity which is installed on their phone is in this list. Since earlier or later they want to start it at least once, and then it will be in this list, so the list gets full and fuller, and this way you exhaust your memory, your main memory. And if your memory isn't enough for starting the next activity, then one of those will be freed in memory, but still be in this list. So we could switch back, but then it goes the left way of our diagram here. Okay, so this should be the reintroduction into the mobile computing and activities, and today we focus on intents. We want to learn lots more about the second important part of Android. This is the intent system, and as we have already talked about, or as I already mentioned, these intents are something like MIME types in a graphical user interface. If I have a file and click this file, the in a graphical environment, the graphical environment gets the double click. Maybe this is a event. This event will be generated. You see here we had the attestation on Thursday for the other students. If I double click this entry here, a program will be started called Notepad++, and this program will then present this information. And this is the same idea behind the intents. So I just want to do something with the phone. It is a user's intent to do something with the phone, and what he wants to do with the phone. So what do you want to do today is the question that Microsoft asked in some generation on some phone, or was it Nokia? It could be Nokia too, somehow. What do you want to do today? And is such a phrase, and that's what the intent means. I double click something and it should something happen. And what is the intent? What should happen then is what somehow the programmer has defined is happening when this intent is raised. So we raise an intent as a user, we click somewhere on the phone or something, some intents will be generated in the background. When something happens behind the scenes, the user isn't it's not visible to the user, it's transparent. Maybe you have a VLAN in the reach, or you have RFID chip in the near field, or you have less battery, maybe, or you are connected to the USB, or you are connected to your battery charger. Maybe those are intents or events too, which are presented via intents, and your system can react on this environmental changes, and that's all is handled over the same kind of system, the intent system. And that's why it is very, very interesting for us to learn more what's behind the scenes. What do these intents do? Which possibilities do we have to make it to our intents? Okay, at first, intent is nothing else than a asynchronous message object related to an action. So we have something like a action that should be happen, and we have a message object attached or related with this action, and it is asynchronous. We throw it somewhere out, and later on, when somebody is able to run with those, to work on those asynchronous objects, he will open your message object, look into what is the action, who can be applied with this action, and then we have a look in lists which program is able to fulfill this action, and this program will get the message object. Maybe in this message object is a path, so if I click here, I will get a program running, and as a parameter there will be the path to this file. This path here will be given to this program, and this program is then able to open this file directly via double click. We know that. And drag and drop is something similar, which is working like this behind the scenes, and therefore we want to have any object-oriented approach. So we have a message object with some content, and the content belongs to the action, so it's related. If the action is open a program via double click, then this double click is maybe on a file, and then this program should open this file directly, and therefore we need some content in our message object, which is the file path. And if we want to ring a contact, we should have a special message object which has maybe the phone number or the contact ID of this contact we want to call. Yeah, we want to ring, and the action should be, I want to call somebody, and there should be a activity or a application which is able to deal with a distinct action, which is able to call somebody if we want to ring or call someone, and which needs then advice, who do you want to call? Yeah, those things are possible, and we start really smaller. We can address activities directly, so we can pass or create actions to special activities as well. So we can start from one activity, we can start another activity using the intent system and have a method called start activity. This is our starting point, and we put a intent into this method, and this uses the intent system. This is the behind the walls. The Android system is handling this intent and chooses then what to do, maybe ask the user or solve the intent by myself. We want to learn this today. The typical use is to start own activities. So this is our first approach too. We want to start from one activity, we want to start another. This is how the user navigates from one screen to another. We present another activity, and therefore you could think about, I have a more complex application with several screens, and every screen could be bound to one single activity, and I want to navigate from one screen to another, and this is how I navigate from one activity to another, and therefore I can use the intent system to switch between my screens. This is a really normal approach, like you find in lots of Android applications, on mobile applications, in the Android system. Because we have the simple solution, use a intent and find the right activity. And you just write activities and provide activities for intents. This was the desired base idea. We can address activities directly. So this is a typical use of intents. Start an activity, or later we can also start a service. A service is a program in the background without user interface, and therefore it's similar to an activity, but the life cycle is a little bit smaller because we do not have so many different stages. We don't have the need to interact with the users. The service has no chance to interact with the user directly via event handling. This is not possible. It just runs in the background and can do calculations or some stuff in the background, downloads over the network, or listen on some state of the phone and and do something in the back the user doesn't see. And the activity is the thing which is in the foreground normally and is presented to the user on the screen, and therefore we distinct between activities and services, and we can use the intent system to start either this or this one. Both can be explicitly addressed. We want to have a look at how to address a activity directly, so that the intent system doesn't have to choose which activity is best for this intent. We give it into the intent, we pass it to the intent by ourselves. We say, I want only this activity run, so this one. And how can we explicitly say that? It's quite easy to do so, and we can address those intents explicitly to activities or services. That's the first thing we want to do, we want to have a look at, and then we can write intents which will match lots of activities, and the Android system should then find out which activity is the desired one. So the user maybe should choose one activity if there are several activities available which could handle the same action. So if I have several activities able to open text files and the user didn't choose one standard activity, the intent system should produce a dialog which comes up in front of the actual running activity, and the user has to choose which program he wants to use to open a address or a URL. Which program would you choose to open a URL? Some users have the Google Chrome installed on their phone. Others have the maybe what else? The Opera browser installed on their phone. Both are able to open URLs, and if you click some URL, the system asks you which browser you want to use for opening, and you can choose one from the list, and as well as you can choose some checkbox where you decide, please remember my choice, and the next time you open a URL, it will be opened with the application chosen before. So the dialog won't come up again, it won't annoy the user again with please choose, and it goes automatically later on, because you have changed something in the Android system with your choice that is persisted there, and if a activity again produces a intent to open a URL. The Android system says, okay, the user has already chosen which activity should be started with this intent. So this is the main thing with the intent system, and we will just now just see how to create those intents, how to use this stored activity. This is not that difficult. We just create a second activity. So this is our first activity. We have seen it already, and we make a new one. I present now a new Kotlin file, which should be a activity. I can say here I want to have a activity, and then I can just create one from here. This is the same thing. I could make a empty file, or I say the typical things I want to do is service or fragment or activity, and I take this empty activity. I come to the wizard. The wizard again asks me some things. I want to have main activity 2 in the same package. Source language should be Kotlin, and then finish this thing, generate a layout for this activity 2. This is what the wizard already does. We learn more about this step by step too later on, but at the moment it is quite good. The generator creates me this app compat activity, but I don't want compatibilities. I want to use the activity which is present on the phone, so I can go over that. But I have to import it. It must be imported, so import this activity. Now it works. Okay, just take the base, the main class activity, which is on every phone. It is present there. I don't need this compat at the moment. Good. Now we have two activities here in our project, and we want to come from this activity to another activity, and this should be done in the first thing automatically, and later on when the user presses a button. So first we go into our onResume method. So this is the last call before the application is going into the running state. And here we can create a intent and call the start activity method. The start activity method is part of the activity class. I can just write start activity and have to input a intent. The intent has to be imported, and then we have some parameters here. This is a empty intent, but we could use parameters here to create a special intent. And one of the parameters we could push into this intent is the name of the class we want to explicitly start. And if this name of this class is a activity class, it can be addressed directly by the intent. So we say de dot this one dot my application activity main activity 2 dot class. But we have in Kotlin, we don't have this class. We have to call this Java. Let's say, go back. Want to create this class, so this is something we already know. And then I just want to have this Java runtime. How was it in Kotlin? We can write something similar like Java to create this. It's a little bit time ago. How to come around with this Java class, because what we want to do is this here, but it does not work in Kotlin because there is no class extension. But we come into this if we write the class name, I think, and write something like Java but I don't know at the moment, don't know how. So we create a intent like this one eventually. This is empty, and we can go into this intent and set some things. Intent, and then we have the action, which is run something, and we have a package 2 and a component 2, which is the component name we want to start. Yeah, Kotlin is lots of time behind when doing Android with Kotlin. I have a look into this Java runtime with the Java class with Kotlin intents or Kotlin intent. So how we come back to the Java classes if we use this compatibility here in Kotlin. The component is the component class we want to start, and this is this component name. Normally it is main activity, but it's not a string, it's the name of a component. So we can't write it like this, we have to write it like a Java class runtime. It is done via, let's say, this one, like this. I think so. We can create an intent like this, I hope. Is it this way? Oh, it's lots of time behind. I don't know. I'm not sure at the moment how it was done. This is the next activity. Yeah, this was. This is right. And moment, this was right. So this is the Java class here, and we have the actual package context, and this is how the intent is created. This is right. So this will be our intent object. Since Android is a Java virtual machine, the Android runtime is a Java virtual machine, and we have to use this Java class. This is like a hybrid expression. We come from a Kotlin class to a Java class. This is the Java class part, and we need this Java class part for the Android system, that it is able to run our Kotlin on top of Java. Okay, and the first parameter is the actual activity, which is the source or the sender. This is the package context. It is the actual activity is a package context, or gives us this package context. Okay, and that is our intent. We can now start other activities with this intent, and there's only one activity we can start with this intent. It's this activity. So we don't have to create some action, and we don't have to create some data, because we only need a address which activity is the desired activity we want to start, and we have to give some context too, because the Android system, which handles this intent, which is a asynchronous object, has to know what is our starting context, because over this context the Android system knows which user ID is used in the kernel, which which application wants to use this intent. Has this application access to this activity? Is it allowed for this program, for this user to start this activity? Yeah. So sometimes you need special rights to do this, and therefore it is really restricted. We need a reference to our sender for the system. It is asynchronously handled by the system. It will work on this activity when the system has enough work time on the processor. So when your device is really small and has to calculate lots of stuff, it maybe gets slower and slower. And if you click somewhere and it doesn't happen so far, then the system isn't able to react on your intent, to handle your intent, and it waits until the next free time to handle your intent. Yeah, it will sometimes, you don't know when this is done. Normally this should be done immediately, but it could take time. If you send this object into the system, it could take some parts of a second, or it could take several seconds until your activity will be presented. So there could be a delay, but normally it will be immediately run. In our case, we just come into the resume method, and at that moment where we come into resume, we create this intent. Immediately we start another activity, and this second activity will come up. And we don't have to do anything, just start the application. And what we want to see is it compiles and installs, and then we should see. Do you want to terminate? Yes, terminate, and then it starts over. We terminate it. Now it comes our first activity, and this is the second activity already because it has no text. To give the second activity a text, we can go here into this. We see there is a layout activity main2. Go in this layout. We see there is a text somewhere. There's only a layout inside, no text, and we could write a text field into this layout. Android text view with a layout which wraps the content. And we should end this text view too. So maybe we want to have some text in this text view. And give it somehow a text. This could be a string, so main activity 2 is the second main activity. So now what is the problem here? I have to no, what does he want to, why it is red? Okay, ignore missing constraints. Good. It's enough to have a layout information and a text. This is what we at least need. And now we should get our second activity visible. So this app stops because of a constraint layout here. We can start with a linear layout. We don't need this constraint layout at this moment, so we could just start over with this linear layout, but we need a namespace. The outermost layout, the outermost node in this XML file needs the namespaces at least the Android namespace that we can access those Android parts here. So let's find out why this application crashes. Here is a fatal exception. Unable to start activity. This is my application 2. Because of binary XML file, a layout width. You must support a layout width attribute. Somewhere we miss this layout width in our binary XML file. Let's have a look where we miss this layout width. We have here layout height, layout width. It must be in the namespace of Android. Now it's correct. Restart the application again. So apply the changes and restart it again. Now we have this main activity presented here in our emulator. Okay, this is the first touch with the intent system. We create a intent object and send it into the system. The system handles it asynchronously in our intent. There is nothing, no data, only the sender context, so that we need to check the rights, if we have the right to start this activity. And we know we have this right because it's our activity made by ourselves. It belongs to the same application package, and therefore we have all the rights we need to start this activity. The user is not able to start this activity by itself because we do not have written down something about this activity in here with a intent category. So there is no launcher to start this main activity, but there is a second activity. The system knows about this activity and can handle intents to this activity here. And without this part in our manifest, we aren't able to start our activity in any way. But the user is not able to start our activity because we haven't defined a intent action and category launcher for this simple activity 2. The activity number 1 has a main action and a category launcher, and therefore the user is able to push this button in the program menu to start this activity, but he isn't able to push a button because there is no button for this activity to start this activity. But we can start it with start activity method when using it explicitly. And explicitly means we write the class in form of the Java class. This is important to say, okay, we need a mapping to the Java class object of this Kotlin class. But then it's explicitly possible. Now we want to do it when the user clicks a button. Therefore we need a button in our layout from the main activity. There we have a text view inside, and in this text, in this linear layout, we can produce a simple button object, and we make it wrap the content like the others do as well. And the next is to give this button a text. So there should be click me on this button, and if we click this button, we want to access a method which then is called when we click this button. So we should define a Android action, which is Android action, or Android is called on click, and we write here the method name, which is called when we click this button. So it should be maybe a button click method, and this button click method has to be defined in our main activity. So this IntelliJ already knows if you write on click, this will be a event handler, and this what you write here is the name of a method, and he checks if this method is present in my class, and when this method is not present in my class, I have to create it. And this method signature should be a button click with a view object. The view object will be this button here. So I can write it by my own. I override, or I write a method fun button click, and I give in our button view. So it should be view, a button derived from view, because the runtime system handles only the clicks on a view object. We know this is a button, and we can cast it to button. Button as button is a typecast, and we can get the text. We can access the text from this button and log it. Button text, so clicked. Let's say this thing to a string was clicked. Okay. We know we actually have this event handler is only used in our button object. Nowhere else. So it is safe to cast this object into this type button. This is safe because we only use it in our button object as event handler, and therefore we get this button. It would be better to write button here, but if we do this, we maybe don't get this method called. So let's try. Just want to see what happens, and at the moment changes were not applied. Adding a new method requires an app restart, so restarting the app. We have a new method, but I think this method won't be called when we click. So furthermore, when we click on our button, the application should try to call a method with a view object, and since we don't have that, it could crash. So what's now? Why it isn't started? I want to start it. Here it is, but it's the second activity. Oh, we have this resume intent. That's what we don't want to do here. We want to do it later down in our other method, in our event handler method there. That's why we want to do this in the event handler. So we now come over, apply changes successfully finished, and we want to restart it. Come on, apply changes and restart. So maybe it does not restart the main activity, it restarts the second activity. I go back. Now we have this click me button here, and I click the button and the application stops, and this is what I told you. It tries to figure out a method, or tries to call a method with a view object, but I don't provide a method with a view object. I provide a method with a button object, which is not good. We need to have to write view here. It would be better from a software development point of view to have a type-safe method call, but we don't get a type-safe method call. We get a view method call, and the type safety, we have to write it by our own. Okay, but now if we try to restart the program now, we get this method called because it's called button click and accepts a view object. We are safe in casting it to a button so that we can access the text attribute and get this value called. So click me will now be clicked. You see I clicked the button and the program did not crash. This is the first thing, and where is now my logcat? It is here. So this time we got the output. I go to the end, clicked me. Click me clicked. So click me is the text of the button and click me was clicked. This is simple. I cast it. I have to cast it here because it's not possible to get the button object. But we could use when. We could use when, and this is typical for when button, and this is save, is button, then do this. This would be much more fun. Then do this, and we can leave out this cast because it is already cast. This object is already cast to a button now, and then we can access the text. And this is fine. When button is button, then it's clear. Else we can say something went wrong. Something went wrong. The event handler was not connected, or was connected with a not button, with another object. Something went wrong. Maybe the event handler is connected to the wrong object. Okay, so this is the Kotlin solution, and I restart the program now, and we do it again. First steps Android, I click the button and we get our text out. I go here, click me clicked, so it works. And when this button is clicked now, we want to start our second activity. I take this out, leave it empty here, put it into this. When it's button, I start this second activity. Like this. So, click the button and the second activity comes up. Good. Have you questions so far to this explicit intent? Every intent can have additional information. It has data, and we can set some data into this intent. And yeah, how to set data to an intent. We could put things into this or extras. It's called extras. Better. It has extras. The intent has extras, and this is the data we put into this intent. We can put some extras into the intent. So put a string and here we have to create a bundle. So this should be a bundle. Extras is a bundle object, maybe to write, to put, well, cannot be, it's a value. It's a value, so we can only put something, I think, put, but it's gray, so it is maybe not able to put into here. So if we give a key and a value, it won't be, it's not safe, so we have to make this like, yeah, it's not type safe. It wasn't type safe. So we give it a key, we give it a name. This should be a name maybe, and this is the value of the name, my value, maybe as a string. So this intent is then handed over to the second activity, and we go into our second activity and try to get this data back. Get this data back. How to get this data back? There is a function called onNewIntent. onNewIntent, and we want to find out when is this function called. This function is called when, I think, when there's not the first, the second intent or other intents come to this activity. So we try it out. We want to have a log tag, and this log tag should be similar to our other log tag. Can have this again as a constant value. Oh, we already have it, so we can use it, reuse it, because it's global log tag, and give the intent into string version into this log. I rerun this application and we try to figure out, is this method here called when the second activity is started? So, and we see displayed something. So it's displayed our activity, and now we click here and we get main activity. Activity manager started another activity. We click the button. This is done by the activity manager. Then our activity gets into pause and gets stopped, because the activity manager displays another application and we do not get anything here. So onNewIntent is not the right place, but if we send more than one intent, this method gets called. We got this onCreate method here, and we can access the intent in another override fun, and that's called onResume. We know this onResume. It does not have anything here, but we should call super on resume, and we can access the intent as well here. Just restart my application. Run it, click it, and now we come into our intent. This is this output. This is the output, and there we see in this intent is nothing else than the component. There's only the component printed, and we can ask if the intent has extras. In our program, we ask if the intent has some extras. And we try to ask, is there a extra called name? We can try to use this one. I restart the activity, go down, and we get false. So this was empty, and since that is empty, my sending the data wasn't correct. I should append something into this intent with set data. It should be set data, and this should be a bundle, I think, and it must be a data object somehow, a bundle, and this normally. Yeah, so, and I can put things into a bundle. You see, put string, and this is my string I put into this bundle, and this bundle can be then used with my data as data. Should be a bundle. So no, this is additional data, so it should be additional data is not the same thing. It is something for if I want to open up a contact, or if I want to do a phone call, then I can give a URI, but it's not the data. The data I want to have is extras, and I need a method which puts extras into this. It is not data, it's not get and set data, it is actually extras. I was on the right thing, but I need to set something and not set data, so I need to put some extras into my intent, which is possible, which is absolutely possible. We can put extras into a intent, but in the on the Kotlin side, I haven't done that for a long time ago. So let's see how to do in the Kotlin from Kotlin code. And we have normally we have put extra and get extra. But the put extra, and now we have put extra. Okay, we put it extra. That's right, not this approach before. So we put a extra value into our intent, like this. It creates a bundle object, and this bundle object has those values inside, we can grab it again over this key. This is the name of a key, and we have a value to, and then we should see it in our second activity. So a extra is a user-defined data, and this data must be a URI, so a uniform resource identifier, which can be a file, which can be a phone call. It's something like the data should be, we talk about, I think, this next week because we have only 15 minutes. So this intent data should be something like phone and then a number plus 49374 and so on, or something like an email, mail to, and some email, something like this, or a file, a URI, a resource identifier. We have a special type of URI, and then we get the rest. So this should be a mail address, this is what the data looks like. It's a special format. It is a URI format, but there can be other special things which are not HTTP or not file URIs, so like phone or mail to, maybe to create or to create an email or open up a email editor program on your phone to write an email. That's possible too. I think we do this next week, to use the intents to open up several programs and to learn which programs are standardized in Android and maybe available on every phone, and have a look how to use these URIs and give extras as well. So if you use some programs, and we use our program again, if you use some programs maybe to write an email, you have a special URI, but you could put extras. Maybe you could use a subject, you want to use some other email addresses to make the carbon copy or the blind carbon copy, and those information you put into extras as well. So intents have data, which is a URI, to inform the application you want to start that it should, what it should do mainly. But now we should have a put extra inside, so we should have extra now. Why don't we have extras? So this has extra name. Okay, we start up the program and now it is true. So now we get this true. We have this extra name and we can print this name. Would check if intent has extra name. We return intent punct get extra or get string extra, and it's called name. This is the one, and the other one is sorry, no data available. Now we can print this in our log. Normally we should be able to print this in our log. Why? He does not want to do that. Oh, toString. Better to have toString here, then both are strings. Now it will go into this log file. And here we see my value now if we start the activity with this intent. This is one approach in using the intents, communicating between your own activities. You start an activity and you have the possibility to hand over structured data in this form. This must not be a string, it can be integer, it can be double, and you get it out again if you ask for your type, but you must have some knowledge about, that's what you see, you must have some knowledge about the type of this extra. You cannot say, okay, it is whatever, and I get it back and do something with it. You have to know, is there a extra and how is it called? To access it, I know to access it I need the name. I have other possibilities to access everything, but then it's a little more complicated, because if I just use these extras and then try to access every extra, I can try to use it in a for each maybe, and print every extra, but it's a bundle, so we should access it with this, or if intent has extras, or intent extras is not null. So now it should be, this is a bundle. So it is a bundle. So we get a bundle and we should address this bundle, and therefore get into this bundle and try to get everything. So how to get everything out of this bundle? Try to get a list somehow from a bundle, and that is only possible with this parcel, a serializable thing. So we get some serializable data, but it is then in these different types. So there's no possibility. This is not made a string. It's a binary data and is serialized binary data so that we don't get any points. We need to recreate it with knowledge. We need to have the knowledge of this name, named attribute, and the type. That's what we need to know, names and types. Okay? Have you any questions so far? So in this moment we are a little bit at the end, and I make the text size Android text or Android font size a little bit bigger. We did it in our other layout here. We have the text size made bigger. So we can actually do the text size a little bit bigger. And now let's try to find out why this text view is
I have a question.
yes, please
It has
ask.
to do with the ID. So, for the XML, the activities, the XML. So, is there like an automatic IntelliSense for the let's say properties that you can use for layouts? So, like the layout with the way it was showing it for the intents, does it also show it for the layout too here?
Yes.
Or you have to make some settings? Okay, okay,
No,
okay,
we have some we have context sensitive help here. We have this code
okay.
completion, but it's the IntelliJ has this code completion because we have this schema here available, and if you have a good XML editor, and the IntelliJ has a very good XML editor, it just recognizes those files presented here, and if you define the correct files inside your XML nodes, then you have correct access to everything what is possible, and it is which values are available. What can you write here is also defined online, and sometimes it is presented here too. So it is defined in this schema file what you are allowed to write here, and then you get some German Vorschläge. Yeah, genau. That's right. Okay.
Thank you very much.
You're welcome. So now I want to have a look why this is not really running here. And this is gray because I don't use app, and why it is used here is just this constraint part, but I don't need those constraint part. I've written Android text view, so I've written Android text view, and this is not correct. It's text view. Yeah, now it is correct, and now it will work here too. So now it will work here too. This was the mistake, but it is working. So the text view is part of the Android application package resources, and therefore you are allowed to write Android here. It's not a mistake, but he says, hey, don't do that. You should define a layout for this. But if I remove this Android, the inflator who is on your phone, who is reading this XML file, needs this Android layout presented as a namespace. So you could write here what you want. Yeah, not really, you can't really write what you want because it's checked, but it's not needed because the program which is parsing this file will not recognize what is standing here. Your Android phone is not making a internet access call to get down this XML namespace file to parse if this file is correctly, because the inflator program which later reads this XML file and creates your objects doesn't need this information because it is the generator program. Yeah, that's why this information is only important for our XML editor, and the XML editor says if you write Android here, you may not write Android here, but if I put this file then in my Android program on the phone, which inflates objects from this XML, this program needs the Android namespace annotation in front of this attribute. Otherwise, it says you miss to define this attribute. That's why I have to write it here, and the XML program says you don't have to write it here. Yeah. So both would be okay. If I can write it here, you have seen it, the program runs, so the emulator is using the XML in a correct way. It doesn't need this Android in front of that. Good. Furthermore questions? So I would say then we have it for today. It is 1 o'clock in the afternoon again. This was our first touch with the intent system, and here we have the explicit intent used to start a other class, we have to recognize that we have to use this .java class version of this Kotlin class version. This is a mapping, and we can put some extras into our intent, which is a structured data. We have to give it a key value and a data type, and this data type is later on received here with a value name. We can test if it is available and can do some standards or not, and this is what you are able to do with the intents and what you should do with the intents always. So use it, please, and as well in your attestation program you are programming. Okay, so this was the lecture from my side. I hope you could enjoy it, and we see us next week. I wish you a nice weekend.
Thank you very much.
Goodbye. Have lots of fun.
Sorry, something just came to my mind now. I wanted to ask with regards to the exercise, because I wasn't around last week. So
Okay.
I wasn't available. So I saw in the question that there is going to be like a second, will I say, a second option or something like that. I'm not sure if I'm correct.
You mean the attestation program?
Yeah. Yes.
Okay. And what is your question? A second option?
So, yeah, I thought maybe maybe I didn't read it well. So this is what we're supposed to do for final attestation.
That's right. That's right. Okay.
Awesome.
At first, I thought about I give you two different
Yes.
types of
That's
program,
what,
but the other type of program would be something with a database of German tank stops, petrol stations, and prices, and it would be a lot. It would be a lot more difficult than this program. So I said, okay, just use the airport
Use
program.
this.
It's quite a nice thing, and we will have some exercises which is doing stuff what you need here, and you are able to use those partial solutions we do in our exercises. You can use it for here as well in here. Yeah.
Okay.
So we
To
want
be
to
able to do
try
solution.
out SQLite. We want to import something in a database. We want to use this adaptive views. That's what we do.
Okay.
So you can do it, train it by yourself.
Sure.
Yeah, you have guides down here, which are quite good. Everything's in English, and then we will do some things to that problems here too in our lecture.
Okay. Thank
Yeah.
you very much.
You're
Thank you very
welcome.
much.
Excuse me, may I ask a question?
Yeah, please.
Okay. About the last line, display of an object on a map. And could you explain a little more about this part? What would you exactly expect?
Okay, this is quite simple. So the
I
smartphones.
think because we haven't studied this part yet, you?
Yeah. That's right. And we don't have the time to say, okay, take the Google Maps API and program something with this. You don't have to do that. It's just simply use an intent and say, please, mobile phone, open this or show me this point on a map. Yeah, this is all. Display an object on a map. How you do that, you can do it if you want by yourselves when programming the advanced Google API or the OpenStreetMap API as well. Could be programmed with this, but the easiest way to display something on a map is say, Android phone, I want to display this on a map for the user. The user wants to see it. Please show him a map and put a pointer there. Fine.
Maybe I should ask my question in this way that when we search for a result of an airport and the connection for the flight, we should show the destination or find the found airport on the map, the location you mean?
Yes, of course, because the longitude and latitude should be in the database. So if you import this database, you should have the provided the information needed to show this object on a map. So the information is already there. It should be
Ah,
there.
the location information is there.
Yeah. It's already in the Open Flights database.
Ah, okay. Super.
Mhm.
Dankeschön.
Bitteschön. Gerne.
Mhm.
Schönes Wochenende. Have a nice weekend.
Schönes Wochenende auch.
Cheers.
Auf
Cheers.
Wiedersehen.
Ça va. Goodbye.